Welcome back for the Chapter 5 review. This review is going to contain all the problems from 7 through problem 14. So number 7 says, given that the sine of theta equals 1 over 5, and that theta is an acute angle, meaning it's less than 90, find the exact values of the other 5 trig functions. So I need all 5, including sine that was given, so I need 6. I know some of you on the assignments were just giving the sine, cosine, and tangent, so I need all 6. So let's draw what this would look like here. Because it's acute and it's positive, it's going to be in quadrant 1. So I'm just going to draw, and remember, my theta is always the angle that comes out from the origin. Okay, so that means this is my opposite, this is my adjacent, and this is my hypotenuse. So, and I know that sine is opposite over hypotenuse, and so we have this. So I know that this length is 1, my hypotenuse is 5, and so I need to find my third side for my adjacent. And that means that it's going to be b is the square root of c squared minus a squared. So b is the square root of hypotenuse squared minus the other side squared. So b is going to be the square root of 24, which is the square root of 4 times the square root of 6, which is 2 times the square root of 6. Okay. So sine is 1 over 5. So that means that cosine is going to be the adjacent 2 times the square root of 6 over the hypotenuse, which is 5. And so that means that tangent is going to be the opposite over the adjacent. So 1 over 2 times the square root of 6. But when we rationalize that, we're going to multiply by the square root of 6 over the square root of 6. We get the square root of 6 over 12. Okay. And then I like to put cosecant next to sine because they're reciprocals of each other. So cosecant is just the reciprocal of sine, so it's 5. Secant is the reciprocal of cosine. And so that one is going to be 5 over 2 times the square root of 6. But when we rationalize that, which is multiplying by the square root of 6 over the square root of 6, we get 5 times the square root of 6 over 12. And then cotangent is going to be just the 2 times the square root of 6. It's the reciprocal of tangent. So the key is knowing what quadrant you're in, drawing the reference angle, knowing what side you've been given, finding the third sine, the third side, and then you can find the trig functions from there. Okay. Number 8. Number 8 says in a right triangle. Okay. So we have the right angle, and we have angle A is 60. So that must be angle A, it's the bigger angle. And then side C, which is opposite the right angle, is 8. So we must have a 30, 60, 90 triangle. Okay. And that's one of our special triangles. So it's good for you to maybe write down. This was from page 432 in the book, the special triangle. So it says that if you go based on the hypotenuse, H, the shortest side opposite the 30-degree angle is always going to be the hypotenuse divided by 2. So that's our hypotenuse. And then the 60-degree is going to be the square root of 3 times the hypotenuse divided by 2. Okay, so that means that we have our hypotenuse 8. So that means little side B will be 8 divided by 2, or 4, because it is opposite the 30-degree. Let's just reference that so we can make a connection. The angle B is 30 degrees, and that is the side B. And then angle A is the 60-degree, and so side A, this is going to be B, A, C. And side A is going to be the square root of 3 times the hypotenuse divided by 2. So that's going to be the square root of 3 times 4. So I would write some information down about the special triangles. It'll just make it easier for you. Then number 9 says, given the point 3, -4 on the terminal side of theta, compute the exact values of cosine theta and cosecant theta. So 3, -4 means we're going right 3 and down 4. So it's going to be 3 and then a little bit longer at a -4. And then we always made our right triangle going up to the x-axis. Remember that. Okay, so that's always our theta that we're referring to. So the terminal side of theta. So this is the terminal side of theta. Okay, so this is going to be a 3, 4, 5 triangle. We've had those special triangles, but let's just show that we've got c squared equals a squared plus b squared. So c is going to equal the square root of 9 plus 16, which is the square root of 25, which is 5. Because we've said that that's that special triangle we've been working with. Okay, so the hypotenuse is 5. So that means we want to know cosine. Cosine is the adjacent over the hypotenuse. And so cosine of theta, this particular angle, is going to be the 3 over the hypotenuse of 5. It's positive. I just did a dash there. It's positive 5. And then we also wanted to know the cosecant theta. And cosecant is the reciprocal of sine. So that would be the hypotenuse over the opposite. Okay, so cosecant theta is going to be the hypotenuse 5 over the opposite, which is, so it's going to be -5/4. So again, you need to draw the point, know which quadrant you're in, and make sure you're drawing your reference right triangle going up to or down to the x-axis. That's super critical. Number 10. So number 10 says, find the reference angle corresponding to 210 degrees and compute the exact values of sine at 210 and cotangent at 210. Okay, so let's draw our reference angle. So it's positive, so we're going to go counterclockwise. That would be pi, which is 180 degrees. So we're going past that, but we're not going down to this would be 270. So we're into this. So you can find the reference angle, a reminder here, is by taking the angle 210 and subtracting up to 180, because we always want to go up to the x-axis to find the reference angle. So the reference angle is 30 degrees, or pi over 6. Okay. And so we could just go to our table that we've been making and go, oh, 30 degrees, sine is 1/2, but sine is negative in the third quadrant. So we know it's a negative 1/2. And then we want the cotangent of 210. And the cotangent at 30 degrees is square root of 3, and cotangent is going to be negative. I'm sorry, it's going to be positive, because cotangent and tangent have sine and cosine together. And so whatever they are, they're always the same. So cotangent and cosine and sine are both negative in the third quadrant. So that means cotangent is going to be positive. So it's going to be a positive square root of 3 in the third quadrant. Then questions 11, 12, and then 13 and 14 are all graphing at least 2 periods. And so I want to make sure that you know there are going to be just a couple graphing on the exam, but I want you to use Desmos, and I wrote that on the exam. I want you to be able to show me. So this is going to be using cosine and sine. This one's going to be reflected. Number 12 is going to be reflected. And then we've got some shifting with the adding of the pi over 4. And then 13 is a tangent function. It's shifted down with the subtracting of 1 afterward. And then secant is going to be a reflection as well, and a shifting to the right. So I'm going to take you to Desmos and show you how I graph these. And the link of this Desmos will also be in Canvas for you. And so number 11 here is 3 times the cosine of 1/2 x. And you can see that cosine, it's 1/2. And so that's why it's shaped the way it is. And 3 is making it a little bit sharper. It's multiplying everything by 3, because cosine at 0 is usually 1, but here it's at 3. And remember, you can see any of these by clicking on them and going to the gear and making the table if you want. And then this number 12 is the sine function. And that is usually 0 at 0. However, it's shifted by pi over 4 and reflected over the x-axis with the negative. Then number 13 is the tangent. And we're subtracting 1. So you can see how that's been subtracted from here at, it's at a negative 1. It's because it's at 0 at a 0, but now it's shifted down 1. And then the last one is the secant, which is the reciprocal of cosine. And it's also reflected with a negative here and shifted to the right pi over 2. So it's got a few things going on. And that concludes this part of the review. So catch me back for the next video, and I'm going to complete problems 15 through 20 together.